Okay, for today we are doing 6.1 day 2. This is about zeros and multiplicity. All right, I'd like you to take a look at this graph right here. And I would like you to name for me what are its zeros and what is it doing at each of its zeros? What's its action? Action? What are you talking about? Well, it's how does it hit at 0? Okay, so like for instance, that's one of my spots. The 0 would be a 2, and it is bouncing. All right, I know you learned this in higher algebra. I know it's been a long time, so let's talk this through a little further. So everybody try to figure out what are the other zeros that we have, and what is it doing at those zeros? Okay, so let's see if you got them. That's -1. That's one of its zeros. And the action at that one, I call it a snake. You might have said a cut through, but this one is doing a special turn that you see, for instance, on x to the third. This is a special way to hit the x-axis where it's making that kind of a snake action. That one, it doesn't have to be called a snake, but you definitely have to know that it has a multiplicity. I'm going to call it an MPY for multiplicity. The multiplicity here is a 2 for the bounce. Those are worth 2. And the snake gets a 3 multiplicity. And last but not least, we have this other root here, -3. You should have at least known that was a root, right? And that is just called a cut through or a pass through. And teachers do have different names for these. If you have a name that you've used in the past for it that you want to use, I'm fine with a different name for it. But it is definitely not a bounce, okay, because it's just going directly through the root. It's not bouncing off of it. And it's not snaking through it like the other one did. All right? And that is a multiplicity of 1. So what does that mean? That means I can write the equation now. I can write the equation based on what I just wrote there. And my equation for this would look like this. Y equals, and for each root, it's 0. Remember, that's the same thing as a root. You have to have a parenthesis. So in this case, for my 2, that was this place right here, I'd have an x minus 2. Now that one's bouncing, so it's squared. It's going up on the right, so it's positive in the front. Notice there's no negative out in the front here. Next, I have my 0 called -1. It's also called a root of -1, so that's x plus 1. Why? Because -1, when put in there, would have to make the equation equal 0. Okay, and then I'm going to say that's x plus 1, and notice that it's to the third power. You can tell when it does this funky squiggling through the root that that's going to be to the third power, or the 5th power, or the 7th power. It could be any odd root except it's not 1. And last but not least, this -3. So then this is x plus 3. And that just had a plain old cut through, and so that has a multiplicity of 1. Now I know if you're good at this stuff, you might know that I don't know what the stretch factor is in the front. I'm going to call it A. We don't know what the stretch factor is, but at this point, we don't expect you to be able to figure that out either. So just know that there is a stretch factor, there can be, and we don't know what it is. We're just going to assume it's just a 1 for now. All right, now I want to give you another one like that, and you have to be able to figure out what the zeros are. That's the easy part. It's just what these numbers are. And you're going to have to tell me what it does at the 0. Okay, and the 3 options are bounce and snake and cut through. And last but not least, the multiplicities. If it's a bounce, it's always worth 2, and that was represented right there. The snake was 3, and that was like this. And then the cut through is a 1, and that's the power on that parenthesis. Okay, so I'm going to give you another one, and let's see if you can do it. Let's have this one go like this. We're going to make it go cutting through there, bouncing right there at 0, and then heading upwards. All right, I'm going to say that this is at -4, and this one's at 0. And I think that's all you need to know. As long as I don't care about the stretch factor, which I don't, you can write an equation for this. I'd also like you to make a little chart like I did for what's the 0, what's the action there, and what's the multiplicity. Multiplicity is the little power that will be on its parenthesis. Then write me the equation. All right, this is all stuff that you learned in higher algebra. We touched on it last time that we had a new lesson, and now we're reviewing that and adding a little bit to it. All right, so one of the zeros is at -4, and what's the action there? That is just a cut through. And the multiplicity there? Well, if it's just cutting through, it's not doing a fancy little squiggle and it's not bouncing, then it's multiplicity of 1. So in the equation, that looks like this. X plus 4, note, this should make it equal 0 when you put it in there, okay? And it has a multiplicity of 1. That's goes right there. Okay, now, what's the next? It's x plus 0. Now, some people would say to just call that x. I like to call it x plus 0, but it is true that x plus 0 is just x. And so sometimes you'll see that at the front right here, you'll see an x in the front instead of having an x plus 0 in a parenthesis. Now this one is a bounce, so it's going to have to be squared. So that was my 0 is 0. The action is a bounce, and its multiplicity was 2. All right, we're covering a lot of really important stuff here, and so I hope you are taking good notes. Some of the things that you learned last time were these. If I give you an equation like this, x squared plus 3x minus 4, you should be able to tell me the x-intercept, the y-intercept, let me double check here that this actually works. 4 and a 1. Yep, that one should work. The y-intercept is where x equals 0, of course, so you can find the y-intercept. You should be able to tell me the lead term. You should be able to tell me the degree. You should be able to tell me the right end behavior, the left end, and you should be able to give me a little sketch of what it looks like. Let's see if you can. Okay, if you can factor it, you should. And I wonder if this one factors. Y equals x and x. And let's see here. If I want to multiply out to 4, I'm going to use plus 4 and plus 1. Now, that's not going to work because that would give me positive 4 at the end. So I need one of these to be a negative, and I'm thinking carefully about which one I want it to be. I think I want that one to be negative, right there. That way, when I multiply this out, I get my answer back. And yay, now I know the zeros. I know all kinds of good things from that. All right, but my x-intercepts, the zeros, are where they're coming up next. The x-intercepts are where y is 0. So something comma 0. And I can tell from factoring it, negative 4 was one of my zeros, and positive 1 is one of my zeros. The y-intercept is where x is 0. Stick in a 0 here and a 0 here, and you'll quickly realize that you get negative 4. The y-intercept is where x is 0, so 0 comma negative 4. Okay, next up, the lead term. The lead term is the number that's in the front. Okay, so the x squared is my lead term, and so I've got a 1x squared. Now, just to clarify, the lead coefficient would be actually the number that's in the front of the lead term. So this right here is the lead coefficient. Okay, next up, the degree. The degree of this one is degree 2. And it's important, if you look here, you won't see any 2, right? You have a multiplicity of 1 there and 1 there. You'll see it when you multiply it out, though. The biggest power when it's multiplied out, that's the degree. So this is a degree 2. The right end behavior. Notice this is positive in front. There's no negative in the front. There's no negative here either. Okay, so this is positive, so therefore the right end is going up. The left end, you decide by looking at this power here. So this power right here was a degree 2. If that's an even number, you want both sides to be the same. Okay, so this one's up on the right, so it's up on the left. Since there was an even number here, the degree was even, then both ends do the same thing. Okay, and the sketch, well, I know what this one looks like. It's a parabola. But even better, I know it goes through these 2 points, and it has a y-intercept of that. Here's my y-intercept of -4, and it goes through -4, 0, and 1, 0, which looks like this. Now, I can draw my parabola. It's not perfect, but that's close enough. There's my sketch of what this one looks like. All right, well, let's see if that's something that you can replicate. I'm going to give you one more, but just a subset of those questions. Y equals -3x to the third plus 5x plus 7. And you might be like, I'm not going to know what the x-intercepts are. You're right. But you're going to know what the y-intercept is. And you're going to know the right end behavior and the left end. You should also be able to tell me the lead term and the degree. All right, I'm going to pause for a minute while you give that a try. Okay, the y-intercept is where x equals 0. So I put in a 0 here and a 0 here, and all of a sudden I've got y equals 7. If you want to write that as a point, the y-intercept is where x is 0, so 0, 7. The right end behavior, that's the key. If there's a negative in the front, it's going down on the right. The left end behavior, well, you look at this, and if it's odd, you know they are going in opposite directions. So the opposite of down, up. The lead term is this whole thing. That's the lead term, -3x to the third. And the degree on this one is degree 3. You take the biggest of the powers. All right, so there's a good review of all the stuff we've done in the past. Here is a warm-up. Identify the end behavior and the y-intercept. By now, this should be like a walk in the park. So I'm going to give you a moment to just try to answer these 2 questions. Okay, the end behavior, I always start on the right. This one's negative, and so therefore it's going down. On the left side, this one has a degree that is odd, and so therefore I do the opposite, up. The y-intercept of it is where x equals 0, so therefore I'm going to end up with that. So if I want to call it a y-intercept, I like to just put x equals 0, comma, 21. All right, now let's go to this one. And the right end behavior versus the left end behavior. But wait, there's a catch here. That is the lead term. Did you guys notice that? You really have to put that in front and say -3x to the 8th plus 7x to the fourth minus 4x to the third. That was a trick question, server. You're right, it was. So the right end is depending on that negative right there, and that tells me down. And the left end, since this is an even power, I want the same as down, so down. And the y-intercept for this, the y-intercept is where x is 0, 0, comma, let me think, y-intercept. If I put in a 0, oh, everything's going to cancel. That's like y equals, everything's gone, 0. So 0, comma 0. All right, let's see what else we need to learn for this. A quick reminder on polynomials. You need to have, you got to be careful, not everything is just a polynomial. Like for instance, let's say I threw an I in here. Ix squared plus x to the square root of 3. You can't have strange numbers that are not real in as your coefficients. Okay, that's this part. And these powers here, notice it says the n's, that's like these powers here. Those have to be natural numbers, and I don't know if you know this, the natural numbers start at 1. So you can't have a power of 0, and you can't have square roots. That's not a natural number. The natural numbers are like the counting numbers, 1, 2, 3, dot, dot, dot. So the numbers as the powers on a polynomial have to be natural numbers. All right, and it does say, if we ever ask you the domain, you just know automatically the domain of any polynomial will be negative infinity to positive infinity. Another thing it's mentioning here, polynomials are not going to do this where they have asymptotes in the middle or they have sharp little points like that. It's called a cusp. They also don't get to have holes in them, otherwise they won't be a polynomial. Holes are a thing, but they're not going to be a polynomial then. All right, polynomials are continuous, and they just keep going like this. They don't have gaps or asymptotes that stop them, etc. All right. This is just a brief mention of the intermediate value theorem, and that is just that this honestly is something that is a calculus topic, and I was talking to a colleague. It's something that we don't have to cover, so I'm just going to say, if your dog was 6 inches tall at 6 months, okay, so this is 6 inches, and this is 6 months, and then at 12 months, it was 14 inches tall, it would have had to go from here to there, and it doesn't have to go in a super smooth way, but there would have to be something in between. There would have to be something in between those two. And if you do this, the 0 version of it, that's saying that if we had one spot on our polynomial that's down here and one spot on our polynomial that's up there, somehow eventually in between these two, it would have to cross there. Ooh. So this is kind of like one of those rules of math that's just stating something that's pretty obvious. If you're going to go from an answer that was negative to an answer that's positive, you'll have to go through 0 to get there. All right, you're going to learn about this next year. This was just a brief mention that it exists. All right, so here's a problem we've already talked through. You should be able to do this one. You should be able to tell me the zeros. The multiplicity, remember that's like the powers here. And the behavior is like the action, what it's doing at the zeros. Okay, so if I were to sketch this for you, I think that would help. All right, and I'm going to say, I'm going to pause for a second and sketch it. I don't think it would hurt for you to see how I'm sketching it. So the roots here are 3, 6, and 9. So that made sense to me that those 3 spots must be 3, 6, and 9. Now, I know that it's positive in the front, so it must be going up on the right. Next, I know the multiplicity here is a 1, and so I know it's just going to cut right through that spot. This one, however, is a bounce. It's degree 2. Its multiplicity is 2. And so that means when the graph goes up here, it's going to bounce off of that and come back down again. Okay. Then this one is degree 5, and that means it's going to make that weird little dipsy-do that I called the snake right in this area here. When it interacts in a strange way, and we'll make it obvious like that, it's always going to be one of those three things. Okay? When it interacts in that way with the x-axis, you know you've got a snake, which is degree 3. All right? Multiplicity 3. All right, let's see. Or, sorry, I said 3, but it can be any odd one. 3, 5, 7, 9, just not a 1. Because if it's a 1, it's just going to cut straight through it, kind of like it does right here. That was a degree 1. All right, now I've drawn you the picture. You fill out the chart for me, all 3 parts. Pausing while you give that a try. Okay, so the zeros are 3 and 6 and 9. Changing to a darker pen here, the multiplicity at the 3 was a 5. I knew that because of it gave me the equation. The behavior there, I call it a snake. I have seen it called other things, but you'd better have a better name than snake then. The 6 0 here, this is a root of 6. It has a multiplicity of 2. That's the multiplicity. And the behavior there is a bounce. And last but not least, the 0 right there has a multiplicity of 1. And we just call that kind a cut through. All right. One more like that. Let's give this one a try. Okay, the zeros. Well, I can do this from the chart. I've got a 0 at 0, and it's got a multiplicity of 3, and its behavior, therefore, will be a snake. This one has a root of 3, also known as a 0 of 3. Its multiplicity is 2, and that's a bounce. I just know that a 2 gives me a bounce. You should memorize that too. Next is this one, and that's a 0 of negative 2. And notice there's no number here. I'm going to put a 1 just to show you if there's no number there. There's, of course, a 1 for a multiplicity. And then last but not least is this one. And that one, I hope it kind of like made you think. You can't get that to equal 0. Think about it. X squared plus 1 equals 0. X squared equals negative 1. Can something squared equal a negative? And you might have thought, well, I just square root both sides. You have the square root of negative 1, which is an imaginary number. So it doesn't have a real root right there. It doesn't have a 0 that you have to identify. Okay, now granted, you could say that there are zeros, but they're not x-intercepts. They're solutions, but only in the imaginary, with you use imaginary numbers. All right, now what if I said to sketch it? I don't know if anybody sketched it or not. I'll give you another second here to sketch what this would look like. Okay, we're back, and I'm sketching it. And I go through 0, and I go through 3, and I go through negative 2. And you might be like, how do you graph the imaginary part? You can't. We just don't. We don't know where it is, and we don't try to put it on the graph. All right, since there's no, wait a minute, I think I missed one. Oh, nope, I didn't miss one. There was nothing for this. That's right. So this chart being empty there kind of threw me off. All right, so since there's no negative in the front, that means it must be going up on the right. Okay, and this has a, this spot is my 3 right here, and so there's got to be a bounce right there, so I must bounce right there. Next, it shouldn't be that sharp, it should be more rounded. Let's see if I can clean that up with my eraser here. Just more of a nice rounded bounce. Okay, now I'm going to go through 0. That's this spot, and it's got to do that weird little dipsy-do thing like that. Now, if you want to just label it and say snake, that would help me to see that you're trying to draw that thing that we again see in the x to the third function. Okay, you know that one's y equals x to the third, right? And that's what a snake should kind of look like. All right, and then let's see. I know this is degree 3, 4, 5, 6, and there would be a 1 there, but then this is a 2 and then a 1, so it's still just 2. Okay, so 2, 3, 4, 5, 6, 7, 8, that's a degree 8. That means this end has to go up also. Okay, and at this spot here, that would be the -2. It was a power of 1, so it just cuts right through, and so that makes sense that right here it would just cut right through that spot and continue up on its merry way. All right. So, last thing I need to really teach you today is this. If they say that this is a 0, okay, that means it makes the equation equal 0. What does that mean? That means if you stick in this number in the equation will equal 0. So let's see if it's really true. 1 to the third is 1, plus 3 times 1 squared, which is just 3, minus 1, minus 3 is supposed to equal 0. And it does, because 1 plus 3 is 4, and then the other part's -4, and that equals 0. So f of x equals 0. It was a 0. All right. So now it says find the other 2 zeros. What? How am I supposed to figure out what the other zeros are if I know that 0 is one of my roots? Well, then let's think about how you could factor that thing. So do you remember how to factor? Hardcore 4-part factoring? Man, a lot of things to know for today. I'm factoring by grouping. Does this ring a bell? I hope your teacher taught you this back in the day. Now I'm going to factor out from this part, I'm going to factor out a -1. And then I'm left with x plus 3. Do you see why if there's a kid that doesn't even know how to factor a regular equation, that right now you're starting to be kind of toast? So that's why I really wanted you to know the top 20. And most of you do. There's a few of you that just have been so resistant, you just aren't willing to take the time to learn that stuff. And now we're getting in deep enough that it's going to be really hard for you. Take the time. Go back and master the top 20. All right. This now factors out to the front, and I have x plus 3. And then what's left after I factor that out is this part, which is x squared minus 1. All right, so if I were to now factor this, I can say that 1 was a 0 of this polynomial because look, if I put the 1 right in here, right there, do you get that this equation would equal 0 then? All right, what's the other 0? Well, there's 2 things that could have solved this one. Let's break this one out here. X squared minus 1. Oh, if you can factor it, you should. Let me make that more clear. That was x squared minus 1 breaks into x plus 1 and x minus 1. There's 2 numbers. 1 and -1 are roots. This is where -1 is, and this is +1. And then this is another answer, and it's x equals -3. So there's my 3 roots. One of them's 1, one of them's -1, and one of them's -3. Now there's another way you could have done that with something called factoring by grouping is what we did, sorry. There's another way you could have done this, and it's called, God, what do you call this? Long division of polynomials. There we go. You're going to learn how to do long division of polynomials, which is another way we could have done that. You're going to learn that in the same chapter. Okay, starting to feel like this video is running a bit long, and so I'm going to just talk. If I wanted to do a problem like this, my goal is to set f of x, this equation equals f of x, stick in a 1, because they said it's a 0, then when I stick in 1, it should equal 0. Okay, and then I should try to factor it. All right, so, oh, this is the same problem as above, so I just look to factor it, and I used factor by grouping last time. All right, so for today, you might think this would be the time you do work time, and it is, except we are going to be doing a few problems on a worksheet today instead of these questions. We're going to come back to these questions on a different day, and I've made up a special worksheet for you for today. That's what I want you to work on for tonight. The key may not be posted until later tomorrow, later from when you're doing it right now, but the key will eventually be posted for that worksheet. Okay, so the worksheet that's in today's folder is what you should do right now. And I know that was a lot, but this is all important stuff. It really is. We've cut out the things that aren't important, and this is the important stuff. All right, that's all I got for you for the video for today. Good luck on that worksheet, and check it with the key that'll come later.